Hello everyone, my name is Desiree Aya from E12M, and I'm here to present the basic rules of integral calculus. Before we start, I would like to present today's objectives, which are to review the fundamentals of integral calculus and understand the basic concepts and definitions. Number 2 is to explain the basic rules of integral calculus. And lastly is to demonstrate the application of integral calculus rules. Before we start today's presentation, we must first have a brief review of what is integration. Now, integration is a fundamental concept in calculus, representing the process of finding the integral of a function. It is essentially the reverse operation of a differentiation. To understand our presentation better, we must first be familiar with these key notations in integral calculus. Number 1 is the c, or the constant of the integration. It represents all the constants that are differentiated as 0. Second is the integral symbol, indicating the process of integration. Third is the f of x, or the integrand, which is the function being integrated. Lastly is the dx, or the variable of integration, indicating the variable with respect to which the integration is performed. Since we are already familiar with the basic concepts of integration, let us now begin the basic rules of integral calculus. Number 1, or the first one that I would like to present, is the integral of a constant, where k is a constant and the integral of x with respect to the x is k dx is equal to kx plus c. If you look at the formula closely, you will only add an x next to the constant and then a plus c. For example, is this one, with the integral of 100 dx is equal to 100x plus c. Number 2 shows what will happen if there is a negative sign. It will only be negative 2x plus c. You will only need to substitute the values. The next one is a power rule. For any real number of n must not be equal to negative 1, then the integral of x raised to the power of n with respect to x is x raised to the power of n dx is equal to x raised to the power of n plus 1 over n plus 1 plus c. Now the formula may look complicated, but you will only need to add 1 to the exponent. For example is this one, the integral of 16x cubed dx. You will only need to add 1 to the exponent and then to divide it by the exponent plus 1. After that, you will need to simplify. 16x raised to the power of 3 plus 1 over 3 plus 1 will now be equal to 16x raised to the power of 4 over 4. Since 16 is divisible by 4, we can simplify our answer like this: 4x raised to the power of 4 plus c. Another example to understand this rule better is this one. X raised to the power of 9 dx, or the integral of x raised to the power of 9 dx is equal to x raised to the power of 9 plus 1 over 9 plus 1. Simplify it and you will now have our answer. The integral of x raised to the power of 9 dx is equal to x raised to the power of 10 over 10 plus c. The next one is the integral of the function x raised to the power of negative 1, or simply 1 over x. Where x must not be equal to negative 1, then the integral of x with respect to x is the integral of 1 over x dx is equal to ln and the absolute value of x plus c. The formula may look complicated, but you only need to substitute. For example, is this one. The integral of x raised to the power of negative 8 dx is equal to, the first step is to put it in its proper form. You can now multiply the 8 with the formula shown in the rule. Like for example, is 8 times ln absolute value of x plus c. Our answer will be 8 ln absolute value of x plus c. The second example is easier. You'll only need to multiply the numerator to our answer. 27 ln absolute value of x plus c. Let's move forward to the integral of the exponential function e raised to the power of x, which is e raised to the power of x plus c. An example of that is this 2e raised to the power of x dx. You will only need to multiply 2 and then you will get 2e raised to the power of x plus c. Another example of that is this one. You will only need to simplify and then follow our procedure. 45 over 5 is 9, so we bring down 9 and then multiply it to e raised to the power of x plus c. So we will get 9 e raised to the power of x plus c. Our next rule is the integral of exponential function, where k is a constant and the integral of x with respect to x is the integral of e raised to the power of kx dx is equal to 1 over k e raised to the power of kx plus c. This rule is simple because you only need to substitute the k or the constant. Since k is equal to 7, our answer will be 1 over 7 e raised to the power of 7x plus c following the formula. A second example will be k is equal to 12. Following the formula, we will get 1 over 12 e raised to the power of 12x plus c. Another rule in the exponential function where a and b are constant, then the integral of x with respect to x is e raised to the power of ax plus b dx is equal to 1 over a e raised to the power of ax plus b plus c. We will only need to substitute. Like our other rule, we will only need to substitute. For example, is the integral of e raised to the power of 7x plus k. Since a is equal to 7, we will only need to substitute it. 1 over 7 e raised to the power of 7x plus 3 plus c. Another example is this one. The integral of 6 e raised to the power of 5x plus 12 dx. Since a is equal to 5, we can use our formula 1 over 5 e raised to the power of 5x plus 12 plus c. Now, you can see there is 6 here, or the constant 6. We can multiply that to our 1 over 5 and we will get 6 raised to the power of 5 e raised to the power of 5x plus 12 plus c. Another rule in exponential function where a raised to the power of x and a is a positive constant different from 1 with respect to x is a raised to the power of x dx is equal to ax over ln a plus c. Like our other rule, we will only need to substitute. For example, 4 raised to the power of x dx. Since a equals 4, substitute a and we will have 4 raised to the power of x over ln 4 plus c. To summarize this video, we discussed a total of 7 basic rules of integration: power rule, constant rule, and exponential rules. Always remember that integration is only the reverse operation of differentiation. If you think differentiation is easy, then integration is easier. Thank you for taking your time watching me present the basic rules of integration.